This will be the first one in the series showing the HVAC-Calcs database program. This program was made on FileMaker. You need FileMaker to run this file in the same way you need Excel on your phone or computer to run an Excel spreadsheet. So here's the file, and we'll do a quick overview of all the calculations and all the items on here. Some of these are just for heating oil business only, and other are more HVAC oriented. First one is pricing. And what you can do here is you can put your minimum prices, your minimum gallons, and it'll calculate what your cost per gallon is. You can add time in if you're doing long distance deliveries. You can add in mileage. Right here you have a customer drop down. You can pick customer profiles or make a customer profile, and that's going to be your cost plus expenses. And there's also a cost by dollars, or if someone says I only have $800 to spend, you put in your minimum price, your minimum gallons, your wholesale price, and it'll spit out how many gallons you would sell to the customer. The next one doesn't take the place of fleet fueling software, but it helps if you're going to make a delivery with a bunch of pieces of equipment. And what you'll do is you'll just enter the totalizer in on the meter, and then when you're done, you can print this out, or you can send a PDF to yourself or to a customer. And again, I will do separate videos showing each feature. Next is delivery by time. This comes in great when you're fueling generators, and you want to figure out the maximum interval you can go, so you're not making short deliveries. And what you'll basically do is you'll put the time in of this delivery, the previous delivery. Will enter from the last time. It'll show your elapsed time. You put in the number of gallons, it'll figure, and the tank size, and it'll figure out and your usable amount, and it'll figure everything out for you. Next one's tank volumes. I preloaded a bunch of tank volumes to help you when you have to stick a tank. For example, you can go to a 1,000-gallon 48-inch horizontal tank, and you'll put in your fill amount. So you stick it, and it's got 32 inches in there, right? It'll tell you have 732 gallons in there. Volume to full, you put in your 90%. If you want to just fill the 90%, it'll tell you it takes 198 gallons to get you to 90%. So that's tank volumes. Pump pressures for oil burners. What you can do is, let's say you got a gallon 20 in there at 100 psi. You want to crank up the pump pressure. You can either look at this chart and get kind of close, or if you put in 1.20 GPH at 100 psi, all these nozzles at these pump pressures, for example, the 0.85 and 199 pump pressure, will also give you 1.2 gallons per hour. A 1 gallon at 144 will give you 1.20. You can add and edit the nozzle sizes. You can change it from PSI to bar. There's a little cross-reference thing in there too. Buffer tanks. You want to size a buffer tank? Minimum boiler output, smallest zone, your delta T you're shooting for, your runtime. It'll tell you how many gallons of size buffer tank you would need. Conversions. These are some simple conversions, Fahrenheit to Celsius. Here's one for calculating your system expansion tank. Height from the boiler gauge to the top and highest radiation is 35 feet. You want to add 5 psi. You have to set your expansion tank pressure and your feed valve pressure to 20 psi. Here's taking pressure from bar to psi to bar. Here's a simple, if you know your dry bulb and humidity, Fahrenheit or Celsius, you can calculate your wet bulb, calculate your dew point, calculate your relative humidity. Here's some decimal to construction tape conversions, inches to decimal and millimeter, millimeter to inches, decimal. Here's a clock and a gas meter. Here's finding out the BTU output of fuel. Here's for gas and here's for oil. That's conversions. Pipe bending. For those who bend copper pipe and tubing, this is a calculator that'll show you how to do all that. You'll take all your measurements off a blueprint, enter them in here, put in the style of bender, all the parameters. It'll spit out where you mark your pipe. You can mark your pipe from one end to the other, make all your marks at once, and then bend your pipe. And then here there's also calculations for different types of triangles. You can do a simple offset, 3-point saddle, 4-point saddle. You can do them in decimal or feet and inch. Here's for parallel offsets. Here's rolling offsets, and here's another one of conversions. Simple conversions, that's pipe bending. Next is approach method, HVAC. For those of you who understand and use the approach method, you would put in your basic parameters. This one gets you going pretty fast. It'll never be as good as Measure Quick, but this is a lot easier because you can just put some numbers in right away. You can get some basic numbers to see if you have to hook up your gauges. And there's a whole bunch of other calculators down here, and we'll show you those a little bit later because they're also in another part of the app. Airflow, AC heat pumps. Here's a whole bunch of calculations. Sometimes I group them together. So here's clocking a gas meter again. Calculate airflow, and you know delta T. Calculating temperature drop. Airflow. This is rough estimating. Airflow, and you know the size of the furnace output, size of evaporator coil, total sensible heat calculations. Calculating a pressure traverse. If you were doing this manually, entering all your static port numbers, putting in the dimension, whether it's round or rectangular. I didn't mean to do that. Let's go back in here. So here's for rectangle duct, here's for round duct. Here's adjusting your CFM for altitude and temperature with a correction factor. Here's evaporator coil enthalpy. This is knowing your return temperature wet bulb and your supply temperature wet bulb. Put your CFM in there, it'll tell you your capacity. Here's psychometrics, property of air. Go down to your return air, dry bulb, supply air, dry bulb, your humidity. Here's all your calculations. And this will give you your delivered tons, evaporator coil BTUs, enthalpy, total sensible, latent, sensible heat ratio, and so forth. Here's calculating CFM for electric heat. Know your volts and your amps, your delta T. Tell you how many watts, how many BTUs, how many tons, and your airflow. Calculating filter face velocity. Same thing. Traversing points for duct traverse. This is pretty cool. We're calculating duct loss. I'm not completely happy with this, but it seems to work pretty well. And you can also bring up a picture. Oh, lost it. You can bring up a picture that'll basically show you where to place your probes and what you're doing there. It's airflow. Refrigerant and charging. Calculating your target superheat. Measuring your delta T across your evaporator coil. There's another calculation. Calculating target evaporator delta T. And a little bit of troubleshooting. There's another chart. You can zoom in and make bigger. Everybody's seen those charts. Target subcooling with a TXV. Additional rule of thumb. Putting your line sizes at your factor. And this is based on, these are standard published numbers. Putting your factory charge, help you out with that. Now, if you have specific additional charge factors from the manufacturer, you'll enter them here to get all your calculations. And calculate your compressor ratio. Changing your PSIA, your PSIGs to your PSIAs and putting your altitude and doing that. That's refrigerant charge. And recovery tank. This will help you figure out two ways. How much refrigerant you can get into an empty tank. You can weigh a non-empty tank, how much space you have left to get into that tank. This way, if you're charging something larger or recovering something larger, and you know you're going to have, you might need two tanks, or you might want to start with a fresh tank. So that's recovery tank. Fan laws and motors. Here's all your fan laws. Calculating CFM, knowing certain parameters, calculating RPM, calculating static pressure, calculating horsepower, determining RPM by pulley diameters, determining belt length by pulley diameters, and requires static pressure change for CFM, and that's when you're doing some balancing. Capacitors. Here's a very nice picture of how to do it. But basically what you'll do is if you had a 440 volt and 35.5 microfarad with the tolerance capacitor, and you happen to read 256 amp. No, you want to read 256. 12 amps and a 330 volts. It'll tell you your capacitor failed. Like I said, there's a chart here to help you out with the calculations. So that's one. This would reset everything. You can also look at parallel capacitors. You have a chart for that telling you put in two in parallel. Here's would be your microfarads, 35. In series, of course, 15 and 30 gives you 8.5, two different capacitors. That's capacitors. Ohm's law, real simple one. Let's say you want to know, and there's just two fields. You measure 240 volts and you're drawing 11 amps. So your resistance is 21.82 ohms. Your power, which is your watts, 2640. You change that from ohms to mega ohms and back. You can change it from amps to microamps to milliamps. And there's a little handy chart here to help you visualize it. I just wanted to show you what the HVAC-Calcs file looks like on the iPad. And this is the preferred way to use it, especially for the pipe bending. So I'll just go right through and show you the screens. We don't have to talk about them. Pricing, gallons, delivery by time. Most of these are the same, except for pipe bending. You can see how much nicer that one looks, and all the calculation fields are on the right panel. Conversions, a little bit easier to use. Approach method looks very good on the iPad, and just a lot more screen real estate. And that's about it.